My name's Tim, and I'm a recovering mathematician. I'm going to talk about, there's going to be a lot of repetition in this talk. I think everybody's covered pretty much all the things that I wanted to cover in terms of motivation, et cetera. So I'll probably go through some of this stuff a little bit more quickly and get to the parts where we talk about sort of our experiences with segment routing and some of the things that are unique about our approach. So as the network evolves, we all see issues with control planes, scale, and complexity. In our core network, we have a lot of protocols running. We used to run OSPF and ISIS, RSVP, TE, LDP, et cetera. We have a lot of encapsulations. Since we run a lot of protocols, we've had the pleasure of encountering many vendor bugs. As our network grows, our forwarding plane capacity has been stressed at times. And in general, lots of growth, lots of stress. There's more. So, we have peering. We want programmatic control over our peering policy. This is something that lots of people have talked about today. We're Microsoft. We have Azure. We have Bing. We have very large data centers. And in those data centers, more protocols, very high device and link counts, all running on commodity switching and forwarding hardware. Even greater vendor diversity, and we still have to support many legacy applications. And the nature of our data center traffic, we have Bing traffic, which we have Bing interactive traffic. We have the things that running a search engine imposes on your network, having to move search indices between geographic locations over your networks. At the same time that you have lots of latency-sensitive traffic. Some of these things we can schedule. Some of these things are obviously not scheduled. So there's a diversity also of workloads. So things that we want. We really want to reduce complexity in our network. We have too many protocols now. We would really like to have fewer protocols. We have fewer protocols. We have less code, fewer bugs. Our network gets easier to operate. The amount of distributed control plane state that we have right now is extremely high. We would like to reduce that as much as we can. We would like to unify our forwarding plane. In our data center, so the BGP is better IGP. So our data centers are now BGP data centers. We don't have an IGP there per se. We don't run OSPF, we don't run ISIS. We use BGP as our IGP. That has given us a lot of, that has simplified the operation of our data center considerably since we have only one protocol running there. Kind of having that same approach to a unified forwarding plane, both in the core and in our data centers, I think is something that we're really interested in terms of simplifying the operation of the network. Vendor diversity is something that we also really like. We have, both from the point of view of sort of, healthy competition between vendors, but also from the point of view of keeping things honest, right? Interoperability. Being able to rely that, not being tied to a single vendor and being able to have multiple implementations of protocols that interop together nicely is a very desirable thing for us. And we're also really interested in increasing the ability to control our networks using software. We're Microsoft. We have a fair number of software developers on staff. We also have a lot of networking expertise. We're developing our own, we have our own controllers that we're building. We have TE work that we're doing. We want to reuse all these things in our core network. And we don't want to have to, in order to experiment and implement software control of our networking, we don't want to deploy another new parallel network. We want to be able to do this in situ, right, in the network that we have. So things that we like about segment routing. We really like that that the forwarding plane is well understood. Right? Everybody knows MPLS. We know how to, we know its properties. It's been implemented for a long time. It just works. In terms of the segment routing architecture, we really like the way that it encourages some sensible engineering trade-offs. There are things that networks do well, right? Networks are really good at distributing topology information. Networks are pretty good at doing things like fast reroute. The architecture of segment routing we've seen several times today in the earlier talks, things like TI-LFA, things like the IGP distributing the label information. Those are things that I don't want to have to re-implement. I've worked at the major switch vendors, switch and routing vendors for quite a while. I know many protocol engineers. They are, it takes a long time to get all that stuff right, and we don't want to have to re-implement that. Again, as other people have mentioned today, removing the per tunnel state from the core is a really nice thing. We get closer to a static core that actually doesn't change often. Our control plane becomes quieter, and these are all things that we really like. In terms of the deployment story, having good interop with the existing protocols so that we don't have to have a flag day or throw a big switch to start introducing new technologies into our network is something that we really like. It gives us the ability to kind of do safe incremental deployment. And the ability to do software control of networking with standards-based interfaces is, again, something that lets us not have to reinvent everything. The use of segments, and we've kind of seen today in some of the earlier talks, the segments are the way that they abstract the different services that we want to implement in the network. It was done at a useful level of abstraction so that we can compose the segments and build usefully paths that cross through the network to do the things that we want to do. Another thing, the use of the Anycast prefix, the Anycast SIDs to get things like ECMP, also very useful for us. So that's kind of the why, and we've sort of seen everybody, we've seen the whys mentioned several times already. I want to talk now about kind of the ecosystem that we envision for building out this technology. So internally at Microsoft, we have something called Autopilot, and Autopilot is our infrastructure for managing. Originally, it was for managing servers in the data center. It's been extended to manage the network as well. The link that if you download the presentation, you can see a link to the page that describes Autopilot a little bit. There's also a white paper that's available on MSR if you're interested. Another paper that we've published is SWAN, which is SDN for the wide area network. So we're actually in the process of deploying this now for our inter-data center networks for traffic engineering. We'd really like to be able to reuse that in our core network as well. We anticipate that we would use something like BGPLS for topology and label discovery. We've seen many other uses of that today. And one thing that's a little bit unique for what we're going to be doing is the use of BGPLU for actually imposing label stacks on the edges. In the network that we're building out, we have a mix of vendors. Some of those vendors have support for SR. Some of them don't yet have support for SR, at least in the code that we're using. So we're actually, what we have, or what we will have, we think, is sort of a segment routing enabled supercore followed or sort of enclosed by a not yet segment routing aware edge, right? So sort of LER sort of around a segment routed LSR supercore. So we'll have our own controller that we write. And then we can use BGPLU to sort of impose label stacks at the edge. Interesting thing with BGPLU is that technically it in RFC 3107 talks about label stacks. Most vendors have not actually implemented label stack support in 3107. But turns out with the routers that we have and the software that's supported there, we can actually push multiple prefixes and use route resolution to sort of to build up label stacks. So we can push a sequence of prefixes, all except the last one of which are not actually real addresses in our network, but accumulate labels via route resolution so that we can do that to actually build up label stacks, even with the software that's out there today. Doing label stacks would be nicer. We've actually been talking with vendors about that. With a little bit of indirection and the use of vanilla BGP, we can actually get this to scale fairly well. What we kind of want to be able to do is we want to be able to separate the creation of an SR tunnel from which prefixes get steered on that tunnel. So if we build a tunnel and present it with an IP address, we can use regular BGP again and route resolution to kind of direct a number of prefixes to a single tunnel. That gives us the flexibility to kind of change the tunnel without having to change a whole bunch of prefixes via BGP. Right. This is a little bit of a non-standard use of 3107. Maybe this can be done a little bit differently, but still with BGP. One of the reasons that we like BGP is that it's something that we understand pretty well, and we kind of have our own implementations of it. So that's part of one of the main reasons for our kind of BGP-centric focus here. Going forward, we're kind of looking at BGP prefix SIDs in the massively scaled data center. And in terms of doing our peering, you've seen the EPE edge scenario described several times today. We're definitely looking at that. We also like the use of BMP for collecting routes from our peering routers, pulling those over into a controller where we can do some sort of globally optimized policy. So some of the testing that we've done. So when we started looking at this, we didn't actually have physical routers yet, but we still wanted to kind of be able to evaluate this technology and figure out how well it was working, how there are multiple vendors that are doing this. Does the vendor code actually interoperate? There are all the scenarios that have been described. How well do they work? So what we did with the help of several vendors is we built out a full emulation of our core network, right, using virtual machines running early vendor code. This is a fantastic way to play with code and to do testing on your network. The ask for our vendors is just give us just a little bit more fidelity here. We can get the entire control plane. We get enough of the forwarding plane to do MPLS, label switching, SR. It would be even easier if if the VMs could give us things like the same interface names. That would give us the ability to do things like take a configuration in our core network and drop it directly into our emulation network without changing anything, and then play with changes in our configurations, do an evaluation of the control plane, see if things are as we expect, and then pull that change back into production. We can do it today without these little tweaks, but then we have to write more software to do mappings between different interface names and host names, etc. So just a little bit more fidelity there makes our lives much easier, please. So as I said, we've modeled the entire control plane here with MPLS forwarding. These are VMs. Obviously, this is going to be much, much slower in the forwarding plane, and you're not going to get the bandwidth. But what we're really interested in here is testing correctness, right? And we also we have a very basic controller that we wrote. I actually implemented BGPLU in that controller, and we drive this via REST to do basically to set up and test all the scenarios that you've already been talking about, that we've heard talked about several times this morning. So, so for example, we went through all the things that, like for example, Stefan talked about this morning. Basic forwarding over an MPLS, over an SR routed network with an MPLS data plane. We went through all the traffic steering scenarios. Push one label, have the traffic take the shortest path. Push two labels, detour it onto a different path. We played with the EPE scenario, tested vendor interop in all of these. We've even done a little bit with doing server to server. A little bit with server to server, right? We found, like we heard this morning from Stefan's talk, a very few minor bugs, very few interop issues. Most of these I'm actually really don't want to call these bugs. These were mostly, we had come up with use cases and scenarios that weren't fully anticipated in either the drafts or the implementations. And discussions with vendors clarified these very quickly, and then we got updated code where things worked as we wanted it to. So this story has actually been, the story's actually been really good. I was, being a former employee of some of the companies that are doing the implementations, I was looking forward to finding bugs that my former colleagues I could make my former colleagues go off and fix. And I didn't really find all that many. So, but when I get back, I am going to go and do a little bit more lab testing now on real hardware, so be ready. Again, as Stefan said this morning, management is a little bit on the thin side still in the implementations that we've seen. For example, he actually saw this morning in some of the CLI output that he had. To look at SR state is sometimes a little bit tricky because it gets embedded in, for example, existing ISIS output. It would be kind of nice if we could kind of extract some of that, to have segment routing specific show commands that would make debugging a little bit easier. And the CLI still feels like it's not quite fully integrated in some places, right? Or the SR functionality has kind of been bolted on to existing CLIs. I suspect this is mostly polishing, and by the time we get to fully ready code, that things will be better. So questions that we have and things that we're still thinking about. Analog of LSP statistics. An SR tunnel isn't really a tunnel. It's just, and particularly the way that we're instantiating them, it's just a label stack. So how are we going to figure out how much traffic is traversing each tunnel? One of the things that we have is we have a fairly extensive sampling infrastructure. I didn't put the paper in. I didn't put the paper in the presentation, but there's a Nanog presentation for a couple years ago called, I think it's a scalable telemetry pipeline. So basically we have a collection pipeline that's horizontally scalable that we can use to get things like sampling data into our big data store, and we can crunch that data fairly quickly. We're kind of thinking that this is one way that we can get some fairly real-time data from our network. I've had some discussions with some vendors around ways that we can actually maybe get some better counters out for this. We understand the FRR capabilities of TI, LFA, et cetera. We haven't yet extensively tested it. That's on my list of things to do when I get back. This is probably the first thing I'm going to do. We really like that. We're really looking forward to seeing how well it works. I was really pleased to see this morning that Orange had tested it and that the testing had gone really well. In the way that we're implementing for TE, weighted DCMP is one of the things that we have little question marks about. Hannes, I was going to put link bandwidth community here because Hannes had already mentioned that, but we may actually use that as part of our solution as well. And then again, sort of the whole OAM suite that, as the technology matures, we expect that we're going to get all these things in nice ways. There's drafts out there for things like BFD for tunnel liveness, again, statistics, being able to see for particular SR routed tunnels is your traffic actually traversing the tunnel the way that you think it is, et cetera. So vendors, it'd be really cool if we could see more working code. Things are coming together pretty well. I had these as questions in terms of the multi-vendor stuff, but I'm seeing a lot of traction here. Earlier, I had concerns about philosophies expressed by different vendors, et cetera. It seems like things have really converged, and that the various discussions, et cetera, are kind of dying down. So I think there's much less concern here than there was before. As we move out from the core and as we start to think about how we would do things in the data center or on the edge, things like label stack depths, et cetera, have been brought up as issues. One of the things that Clarence talked about this morning was this notion of a binding SID. And we think that that binding SID is a really useful tool for getting a little bit of indirection and sort of, again, hiding the implementation of something like a service or a feature or a path that is composed of many labels, and actually kind of hiding that behind one label that then gets advertised into the data center. And it kind of feels like that's the right technology, especially if you can combine that with the notion of anycast prefix. All right, so the anycast SID. Anycast SIDs, I think, are another really useful technology for handling a lot of these scenarios. And then, the segment routing architecture talks a lot about the engineering trade-offs. And as we experiment with how this gets implemented, what is just what we put in our controller, what remains in the network are still things that we think about quite a bit. I've already mentioned indirection. Scale out for us, scale out for us. I mean, one thing that we do have is a lot of servers, right? So being able going back to Karidi's talk yesterday, and one of the things that I struggled with as a developer and have seen seen customers struggle with was the constraints of computation in the control plane on routers, right? And so being able to for us, being able to pull some of that computation out and run it in our compute infrastructure seems like a really powerful thing to us. As we explore this technology, I see more and more use cases coming up for it in our network. And so, kind of working with our internal customers that want to use our network and seeing if we can apply this technology to solve their problems is something that's going to, I think, keep me busy for a while. And then finally, something that I'll be working on with my colleague Mohan when we get back is how would we actually go about doing the implementation and the migration of introducing this technology into our network, right? So we've thought about it a lot. We have, I think, still a fair amount of work to do. It looks fairly straightforward, but experience has said that things that look straightforward sometimes aren't. So we're going to. I think we still have a fair amount of work there to do to get to the point where we're going to be actually comfortable to integrate this. So I think that's about all that I have. Thanks to Clarence for inviting me to give a talk. This is my first time at this conference. I've really enjoyed it. It's been a really nice time. I've learned a tremendous amount. So thank you.
We have time for questions just before everyone gets up to leave. There's plenty of time before lunch.
No questions on Windows 10, please.
And I'm going to start off because I really enjoyed your talk, and it was a great first talk at the conference.
Oh, thank you.
So thank you very much.
It's actually the second time I've given this talk, so that makes it a little easier.
Cool. Excellent. Anyway, so you did say that you're looking forward to getting back to the lab to do some more testing, and then you have to start working out on the integration plans and so on. So this is probably putting you on the spot, But do you have any sort of timeline for when you think you might be able to start field testing?
It is putting me on the spot. My answer is that you know, I want, you know, we're still in the process of doing deployments of the routers that are actually going to be doing this, right? So I have to wait for the routers to get installed, right? So they have to be running in the field. I would like to do it as soon as I can. What actually happens, I don't know.
Sure.
Yeah.
Okay, any questions from the audience? Okay, there's going to be a microphone coming to you. So please wait for the microphone.
Hi. My question is, you said you want to build a core which is enabled with segment routing, and then the edges are going to be still taking time to catch up. So you also mentioned you have LDP and RSVP and OSPF and ISRs, a lot of control plane state. So my real question is, what of these existing protocols do you plan to eliminate first, so to speak?
Okay, I can actually answer this. So we've already eliminated OSPF, okay, for the most part. There are a few little places in the network where, around the core, we still have to speak OSPF to legacy data centers. So OSPF, gone. So we're pretty much ISIS all now. I suspect that we're going to have, you know, like George said in the first talk this morning, I think that we probably will have RSVP-TE and LDP in the network for a while. I would anticipate that we greatly reduce our reliance on those protocols, sort of as we ramp up. You know, if we are able to successfully deploy this, then I would expect those to ramp down, and that at some point we could either eliminate or greatly reduce our dependence on LDP and RSVP-TE. That's our hope.
Okay. Thank you.
Yeah. Anything else? I'm kind of I'm standing between these people and their lunch, so I'm
Any more questions? Okay, great. I'd like to thank you very much. Lunch again. Lunch starts at 12:30, and it's only about 5 past now, so you have 25 minutes to...
They're on the low latency path to lunch?
That's correct.